Hello and welcome. In this video, we're going to be recreating one of my favorite student-generated game ideas. So in this game, you have these arrows that point in a random direction, and you actually have to push the microbit forcefully in that direction, and eventually the game will calculate your best time and your total reaction time. So one of the buttons is going to give you your best time in hundredths of a second, and the other is going to give you your average reaction time. And to tell you where I got this idea and a bit about its history, I'm just going to switch the slide here. And so last year I spent 6 months teaching at a university, but we taught high school students and we were teaching them how to do basically project development through design thinking with projects. And long story short, the scenario for a group of kids in various years 7 to 10 was the following. They were helping an injured athlete who had a brain injury. We had two athlete candidates, and one's name was Kadina Cox and another one was, I forget his name, but he was a snowboarder. Regardless, you have this injured athlete who's had a brain injury who needs to recover their balance and reaction time. And the only tool they had was a microbit, and they had to design a game that would sort of improve the physical and mental performance. Something that would be fun and compelling to play. So this was, I believe, Kadina was the athlete in this case, and she had less motor function in her left arm due to her brain injury. And so she would get this training thing and she would push these devices in random direction and compare her reactions with the left and the right arm. So I thought that this particular one was a really good idea. It wasn't that difficult to execute. Kids actually programmed it over 2 days with block coding, but I'm going to do it today for you guys with Python. Here's maybe I'll just show you a more detailed slide. Essentially, the concept is there's like you've seen it, an arrow in the random direction. You have two microbits, one in each hand, and you get to compare performance over time. That said, before I even get into programming this, I think it would be absolutely awesome if, as an inspiration, you guys suggest microbit projects below. And I promise I am going to actually create some of them on the microbit. The only criteria is any game you can imagine, any concept you want to use, but it has to be done with just one microbit. Okay, let's get started. I'm just going to get out of this, get into Python editor, and we can rock and roll. So what do we need for starting in this game? Well, we're going to need obviously random. So I guess we could import random. And the first thing I want to do is just generate that random, sort of like a random choice of that list of arrows. So Python allows us to use lists really productively. You can use these with sprites. You can use these with images. So if I have a thing here that says arrow, so this is going to be a list. And this is image.arrow. So we've got north, south, east, west, right? So we got arrow n. So the others are going to be, north, south, east, west. So I can replace that with a capital S, E, W. So now if you have that list of arrows, that's going to be, I reckon that's going to be our starting point. So here we're going to create a random arrow, right? Image equals to random.choice arrows. And then I can display.show, and I can show that image. So let me plug the microbit in. Really, this should be fairly straightforward. We shall see, however. This should show a random arrow. So I'll click download. We're putting it on the microbit. Come on. Don't be scared. It's downloading. We should get a new image every 2 seconds. 1, 2. So we've had right and left. Let's see if it goes up and down eventually. We have east, west, north, south. Yeah. Probably should have done more than 2 seconds. But look, so far, so good. Okay, so we have a random dot choice for the image. We're going to get rid of the delay because the delay is something we'll actually measure through the reaction time. What else are we going to have? Well, if we treat this as like a game, like a Boolean, right? Like game on, game on equals to true, and then that could be while game on. So you have a random image. We're gonna need to record the time that you react. Now let's actually just do one single round, and then we'll figure out how to record the times and do the averages and all of that. So we need to now, within the game loop, work out what a reaction time test looks like. So I guess I can just do another while loop. So test on equals to true. So there's a test on, and we can generate a starting time and a finishing time using the sort of existing time tracking that is on the microbit. Let me show you what I mean by this. So imagine you have start time, and that is the time since the microbit has been running, right? And we are going to then take this time when you react in the proper way. So what does that look like? While test on, we're gonna need 4 if statements, 1 for each arrow, right? So if image double equals to image dot arrow. So north is easy. Let's do north first. So north is y in the positive direction. So if you go north, then you're going to say and accelerometer dot get underscore y. If this guy goes up by more than 1500, then you've reacted correctly to that arrow, right? And if you've reacted correctly to that arrow, you can get out of the test. Test on equals to false. And when you are done, I guess when you get out of this, you can display dot scroll. We need to scroll the time, right? We can declare time to be t equals to running the current time, so running time minus start time. So this should give us the time it took to react correctly. However, we're only reacting to one arrow here, so we may just, we may also want to round this to a certain number of digits. I think the default is 2. So let me just type in round, and we'll see what comes out. We'll see, and then we'll display dot scroll string of t. I wonder if it can scroll like a floating point number or whatever. But we are measuring time. I'm pretty sure that this is going to work. I have some doubts of the units of time. However, in order for this to actually work, we have to handle all 4 cases. So I gotta have 4 if statements. All right. So if that's y, I guess that would be less than minus 1500, and that could be south. So that is north and south. The next 2 are gonna be east and west. And I'm just a bit nervous because if I've made a mistake, I've made actually now 4 mistakes, but we'll find out. So we're getting x this time, and we're doing north, south. Now we're gonna do east, west. The east is going to be the positive one, and the west is gonna be the negative one. Sure. Okay, I mean, this could already work. This could already work. Yeah, why don't we just download? I'm fully expecting an error. I mean, we've written 28 lines. Something is gonna trip up. Okay. Oh, no, like 16. All right. This is huge. 6. I guess I'm just getting the number in milliseconds. So maybe just divide it by 10. And if I get a number that makes sense, maybe I should just add some brackets. How about if I do it like this and like that? So if we're getting milliseconds, what we really want is hundredths of a second. It's just easier to wrap our heads around. So if I was to download that, and if that worked, eh. 134, yep. Yep. Beautiful. 48, that makes perfect sense. Okay, so I mean we've got working code here. So what do we do next? We can actually have a list of times, and if times is a list, then we can append the t. So we can add the t to times. So whatever happens, whatever the t is, we can times dot append t. So we're adding that to the times. And if you want to scroll it, I mean, we can just do this at the end, right? So you append the times, and this thing keeps testing, but I wonder if we can exit if, say, len of times is greater than, let's say we do just 10 tests. It'll be easier for us now. If length of times is greater than 10, then we can say we're out. We're out of the game on business. Game on equals to false. And I guess we're gonna need some sort of a display of score. So I'm gonna be completing most of this now. So while true, do something like this. If button a dot is underscore pressed. So if you press button A, we can do the average, for example. So what does that look like? We can display dot scroll AV plus string of sum of the times divided by 10. Sum of times over 10. Or no, I think sum of times, and then you divide it by 10. Bing, bing. And so that would be the average for button A. And for button B, that would be best time, and that would be just min. The min of times, and you don't divide by anything. Wow, could this be the whole game? We should really do like a get ready bit, but let's not worry about it like right now. Okay, that's uploading. There's a distinct possibility this is gonna work perfectly. No, I knew what happened. Line 28. Well, what's your problem? Times.append. Yeah, I have a feeling we might just have to, because it's possible that none of those happen, right? We get an image on and none of those happen. And we exit out of the test and then the times doesn't get read. So what if I only appended the times within the actual if statement? Because t wasn't defined in that case. Let's see now. But I gotta say, I'm impressed with myself. I haven't made any errors until line 28. That's we might be losing educational value for you guys, though. It's probably in some sense better that I make some errors. Oh, when you're done, the display doesn't clear. So now we have the best reaction time, and that was 0. Wait, average, no, average was 42 hundredths of a second. And, oh, that should have been button B. And when we are done, when we're done, maybe instead of clearing the screen, we should just say, before here, something like done. Display.scroll done. And then we can add a get ready, and we are good to go. Display.scroll get ready. Ping, ping, something like that. Yeah, that should be good. So when it's done, it's going to say done. We forgot to put the B. We're looking at 18 minutes. I mean, this is actually surprisingly quick. That list of arrows was really handy. So now we're going to have a get ready. Get ready. Dash, dash. Poo, 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 poo. Now it's going to say done. And we could do best as well as average. So best was 0. Somehow the very, very first time it appends always seems to be 0. So maybe I'll just hang out and try to figure out that. So you have running time minus the start time. And quite possibly, the first reading of the accelerometer on the microbit is sort of, it does happen with some sensors, potentially the light sensor as well. Like it does an anomalous first reading, which would trip T like instantaneously. I mean, you could just call the accelerometer. I know this is very, very how do I put it? Unorthodox. If I was to just call that function there, it's completely pointless. But let's trust me on this one for a second. So we're going to have start time here. The running time is going to subtract start time, and that's going to be the time. The other possibility is that if you divide by 10, one of my reactions was so fast that when you divided this by 10, and that's also possible because maybe as I am pushing in one direction, what happens, and this is more likely, is that I could trip, for example, I get 2 right arrows in a row, I trip them both with one shake to the right. And that would explain how we get a 0 reading. So how do you fix this? Well, every time you generate a random error, a random thing here, you could perhaps put a delay after appending the times. So sleep 100 and then display.clear, I guess. Maybe sleep 200. This isn't that elegant, but it will solve the problem. So with the 2 things that I did, I don't like that I've generated too much code that it leaves the screen. But with this sleep, it basically, you cannot solve 2 problems in one go. It has to be one at a time. And with that, you cannot get an anomalous accelerometer value off the bat. So I'm going to run this and try it out. And this time, if the best time isn't 0, we have implemented all of the functionality. So we are getting ready. 1, 2, bing. Ah. This is much easier if you're not within sort of a limited space, but let's go. What do we do to check if the best one is? B for best. Please don't be 0. Yes. So there you go. Everything works. Well, I hope you really, really enjoy doing that one. I'm going to take this video editing tool, put myself back on full screen. I'll invite you to check out our other microbit Python tutorials. At this point, we're like on around 7 or 8. What do I recommend? A general introduction to micropython, which I'm going to put there, and one that uses a balance dot. It uses like a balance dot to collect little dots. So check those out and do like and subscribe. That's it. Bye-bye.